Hi everyone, it's Misha from Primary Engineer and welcome to our online interview today featuring Dave Woodall. Just before we get today's presentation, I'm just going to run through what's going to happen during the session. As a lot of people watching this event, I've muted everyone except for myself and Dave throughout the session. Okay. So I'm going to give you a little bit of an overview of the competition and what that entails. But for now, a little bit more about what's going to happen today. So the first part of the event is going to be presentation, as I said, and then you'll have chance for your question and answer section. You can type your questions at any point during the session, and I'll keep an eye on the chat box. And then as soon as we finish with the presentation, we can get straight into answering as many of your questions as we've got time for. Okie doke. So our Leaders War competition that hopefully you're all taking part in is to inspire all of you guys to look at the world around you and design a solution to a problem. Okay, so this can be something as small as trying to get out of bed in the morning to a whole worldwide problem we are experiencing now, and see if you can design an invention to solve it. Okay, so we provide opportunities for you to meet and interview engineers, just like Dave today, and inspire you to think of ideas and start designing some inventions. Okay, so to help you with this, we've got lots of resources available online that you can look at alongside coming to these interview sessions today. So our suggestion is that you make this your weekly challenge, so you can interview different engineering professionals from different sectors, and they can help you look at different parts of the world and problems that you might face and be able to design your inventions for, so that when you're in school and in the classroom thinking about your designs, you've got lots and lots of ideas to help you to be able to create your invention. And then once you finish your inventions and you send them in to us, we get engineering professionals to read and grade all of your designs and then give you certificates to be able to reward you for your inventions as well. We have also launched a new project called Stat Wars, and Stat Wars is a data project. So if you or your teachers are interested, you can have a little look online and have a go at those as well. Okay, so I'm now going to pass you over to Dave, who is going to go through a presentation with you about his career in engineering, and then he'll be able to answer all of your questions. Okay, so I'll pass over to you, Dave.
Thanks, Misha. I appreciate it. Can I ask, is it okay to share my screen just now?
There we go. Stop sharing mine, so you should be able to share yours.
Wonderful, wonderful. Can you see that okay, please?
Yes, we can.
Fantastic. That's wonderful. Okay, so as Misha said, my name's Dave. I'm really pleased that you're able to spend a few minutes with me. So thanks for giving up your time to have a bit of a chat. And I hope we can have a bit of a discussion at the end here. I've just got a couple of slides that I hope you'll find interesting, maybe even amusing if I'm really lucky. So as it says on there, I'm a design engineer. I've been working with a variety of roles with TechnipFMC for about 7 years now. And that includes starting as an apprentice and working my way through to where I am now. And it's a fun job. So who am I? So there's some pictures on the top right of more or less what I look like just now. There's my wife and my wee boy who's about 2.5 now. So born and raised in sunny Ipswich down here in the east coast of England. Very lucky I had some really loving parents who wanted to push me to be the best version of myself that I could be, and I'm really grateful for that. I think my parents' expectations for me was that I would go to uni straight away. Although honestly, you know, as a school leaver, I had absolutely no idea what I wanted to do with my life. So I decided to join the army instead. Again, the army were very good to me as well. They let me start as a reservist, which means I could do my A-levels as well at the local college. Shortly after finishing my A-levels, they shipped me out to Germany and subsequently to Afghanistan. And it was while serving over there as a 19-year-old laddie that it really clicked that engineering is what I wanted to do with my life. After getting demobbed end of 2011, decided to move up to Scotland, where my girlfriend and now wife is. Had a little job in a timber mill, and then TechnipFMC took me on as an apprentice back in 2013. So there's a little bit about me. Oh, sorry, I've forgotten about these pictures. There's yours truly, second from the left. It's quite nice to see these old pictures before I had to grow a beard to hide my extra chins. So yes, for your enjoyment. And here's a picture from more recently. This was when I was in charge of setting up a rapid prototyping center, and I'm really grateful to have had the chance to work with an amazing team that you can see there. Everyone really pulled their weight, really dug out to make this place excellent. So, why I love engineering? This was the epiphany I had, or this was what I realized while I was with the army in Afghanistan. That I like to be artistic and creative, and I also was quite good at maths and science. I never really knew that engineering was a career route beforehand, but these two sides of my personality, I think, make me quite a good engineer. And hopefully you might consider it too if you find yourself in the same boat. So just a quick lowdown here on two potential career paths. Now, we need scientists and we need engineers. They're both really important. They're essential to keep the economy going. They create new products and services and make everybody's lives better. Both of these roles do that. But there's a subtle difference between them. A scientist will ask, what's the answer? They're looking to test theories and work stuff out. How can you prove and disprove it? An engineer wants to ask, will it work? So, for example, they're not necessarily very bothered about the particular stress or strain going through a piece of material. They just want to know that it's strong enough to do the job. The other things an engineer might ask is, how could it break? How could this product, service, process, whatever? How could it go wrong? And how can we make it better? So, a quick introduction to my work. This is a corporate slide from TechnipFMC globally. Now, I'm sure you can see from the footprint there, it's a big company. We've got 3 global headquarters, London, Paris, and Houston. We operate in 48 countries, and at last count, we've got about 37,000 employees that represent about 126 nationalities. So it's a big operation. We do lots of stuff with the energy industry in the world, and there's lots of opportunity to move about. And yeah, see your dreams through. So here's a cool picture. That's an ROV, work-class remote operated vehicle. You'll see the little arms up front. It kind of looks like a T-Rex. What that is used for is for grabbing onto subsea infrastructure and manipulating valves, stuff like that, so that we can extract hydrocarbon, that's oil and gas reserves, safely and efficiently. Another nice picture here is a typical subsea layout for quite a large field. You'll see what we've got here. We've got some Christmas trees. I'll come back to why we call them that in a minute. They're effectively like a tap, a set of valves and stuff which sit on top of a wellhead and help to control the flow of oil out of the ground safely, efficiently, ethically. They'll tie into manifolds which collect several lines together. There's also a bit of subsea processing down here. So, for example, this stack, that could be separating out some of the water. So, of course, when the oil comes up out of the ground, it's not just oil. There's also stuff like sand and water and other chemicals that we don't really want. So, if we can sort them out on the seabed and pump them back down into the well, then it's keeping it much cleaner for everything on topside. So, why do we call it a Christmas tree? Well, it's a historical thing, really. I hope you can see from that picture on the left. What you're seeing there is a surface Christmas tree. And again, it's doing exactly the same job. It's sitting on top of your wellhead. There's a pipe going down into a reservoir below that's got oil and gas stuck in rock. And the oil and gas is going to come up under very high pressure, like a fizzy bottle of Coke. If you've shaken that and you try to release the lid, it really wants to come out. So you need this this set of valves and pipe work to control that flow safely and make sure none of it leaks to the environment. This crude oil is really bad for the environment if it leaks out, and it can also be dangerous for people, which is why we design our products so safe. The Christmas trees, like the ones that you were seeing on the last screen, this is what they look like in real life. This piece of equipment here is going to weigh about 30 or 40 tons, which, you know, you're talking maybe 20 or 30 cars altogether. It's a big, heavy structure, and that's because it's got to survive underwater for 25 years, and it's not got to break. It's got to be really safe, and it's got to not leak. So, if any of you are wondering about the ethics of oil and gas production, if any of you are wondering that maybe the world would be a better place if we just stopped, you could argue that. But the fact is that the oil and gas industry as a whole provides heat, light, and power to people across the world globally. In addition, a company like TechnipFMC really values the ethics, sustainability of the whole operation, and we really try to give back to the communities that we're present in. For example, in Dunfermline here in the UK, we support a lot of local charities, do a lot of work with local schools, etc. Maybe more poignantly, in places like West Africa where there's less infrastructure, we do a lot there, helping to, for example, put in the infrastructure to provide healthcare, education, etc. So we really live by these core values. And while you can argue about, whether the oil and gas industry is a net good or bad thing, we need it, and I feel like it's the best thing for me to be working for an ethical company like TechnipFMC. So, some cool stuff I've worked on recently. Worked on this week. It was actually last week when I pulled the slides together. But here's a piece of framework. Now, I was working on this little piece of framework. It might not look much. It's the little red piece that you can see here. And I was just wondering, when we're assembling this thing, what happens if a fitter happens to stand on top of it? Which can absolutely happen. They can be climbing over it, etc., or they're trying to get into screw-in fittings and put in pipe work, that sort of stuff. So I thought, it looks like it could be a bit flimsy. Let's do the maths. So you can start off with a very simple force diagram. You've got the weight of the panel, the weight of the fitter, and you've got these two studs holding it in. Now, it's really conservative. It's not really meant to give you the answer. It's just meant to tell you whether there's a risk or not. And as it happened, it showed there was quite a high stress. So we can take it to the next stage, and we can do a finite element analysis. And that means that you're using software to break that model down into tiny little chunks, and then each chunk operates as a separate element, which can be distorted and moved about. By doing this, we find that there is actually quite a high stress on this area where we envisioned. So, what can we do about it? We can put a slightly beefier bracket in. That's one way to do it, and you can see there the stress has come down quite considerably. In the end, though, what we decided to do is just to change the assembly sequence so that a panel at the front gets bolted on first, and that stops this side frame from ever being unsupported like that. Again, it's all about it's all about doing the ethical thing here. Our fitters who are putting this together deserve to go home in exactly the same condition that they came to work. We don't want anyone to have any safety incidents, and it's this sort of check as an engineer that you can do to make sure that people are safe. Okay, so coolest thing this year. This took me a bit of thinking about, but I think it's my THOJ. That stands for Tubing Hanger Orientation Joint. You'll see it sat here. The people here are just from Google, but it's just to give an idea of scale. This thing is massive. Okay, now to understand what it does, it hopes to orientate a tubing hanger within a wellhead. Now, a tubing hanger is it's a shoulder that hangs your production tubing, like a big drinking straw going down into the oil well, ready for us to slurp up those delicious hydrocarbons. Now, if you think of a Coke can, which I've not got one around here, if you turn the tab the other way, then it's got a little hole that it holds your straw. That's a little bit like what a tubing hanger does. Okay. Now, depending on where the tubing hanger sits at an angle, that depends when you drop your Christmas tree on top, what angle the tree sits at. And for this particular project, the tree had to live in a template, so it was really important that it faced the right direction. That's what this tool does. So in this riser, which I've just included a picture of a crane next to it for scale, there's a pin. What you'll do is you'll drop your landing string that includes your tubing hanger and your thodge, and you'll drop it all in. You'll land it, the pin will shoot out, and then you'll pull the thodge back up again, and it will twist around on this helical profile here, so that once you've lifted it, you can drop it back down again, and it's going to be in just the right place. My absolute favorite thing about the thodge, though, is it looks a little bit like a Pokemon. You know, you've got your eyes here, a big toothy grin, a bow tie, and some little arms out front. And I really enjoyed working on this tool. There's obviously all the peripherals that go with it. We had to have tooling to handle this thing from either side, because it's massive. You know, the thing weighs about 2 tons, like a car. So you've got to have all the tooling to lift it, carry it, assemble it safely, all that kind of stuff. A test stump to test it, so that we can try interface it all together, make sure it all fits before we run it subsea. Loads to do here. Ended up using about 1,000 hours, which is, you know, like 6 or 9 months worth of work. So loads of time. Thoroughly enjoyed it. Really interesting. Ask me more about it if you want to. So as a final thing, just before I close up, I just wanted to offer you guys some general advice. Now, regardless of whether you want to be an engineer or you want to take some other career path, I think these tips that I've just picked up along the way, and they've really helped me out, and I hope they can help you out too. So first of all, try to learn how to learn. This can be really difficult when you're at school, because you'll tend to be given the answers that you need for the tests that are coming up, and you'll always be given that, and it becomes quite difficult sometimes to figure out what you need to know elsewhere. But just try to have a hunger for figuring stuff out. You know, ask yourself, ask open questions. Ask why animals behave in a certain way, or why certain things are certain colors. If you've got access to a computer or a smartphone, you've got the wealth of human knowledge at your fingertips. So just get excited about it. Get hungry to learn it. So in addition to curiosity, I think it's also important to recognize our optimum level of effort. That's when you can make something that's really good, but you also don't spend too much time on it. It's a real personal struggle for me, this one, because I'm a bit of a perfectionist by nature. So I tend to work on stuff even after it's already pretty good, to make it better. And that's good in some cases, but a lot of the time you need to balance it. For example, if you're writing a book, you want to at some point publish that book, and it's never going to be perfect because it was written by us, it was written by humans. But nevertheless, you need to get it good and you need to get it published. So yeah, trying to recognize your optimum level of effort. At school, that might be, study enough to get an A, but don't study night and day and miss out on all the time playing with your pals or whatever. Favorite quote of mine: if it's worth doing imperfectly. And if something goes wrong, allow yourself to fail. That's okay. It happens sometimes. Learn from it and move on. Number 3 thing is to trust your gut and take measured risks. I don't mean in terms of safety here. I mean more in terms of like the risk of being embarrassed in a situation. So, it's important to make new friends. You have the confidence, go and talk to new people, make new friends. If you don't ask, you don't get. If you want that job as a paper round or whatever, go ahead to the local news agents and see if they'll give you it. They might say no, but they might say yes, and it might be the best thing you ever did. So yeah, trust your gut, go for it, speak up. I think that's everything I've got for you guys. So yeah, thank you very much for your time. I do appreciate you stopping whatever you're doing to to listen to me. I hope you found it enjoyable, and I'm really pleased to take any questions. Thank you.
Thanks, Dave, for that. Do you want to stop sharing your screen so we appear a little bit bigger? I'm just thinking, just so everyone can see us. There we go. Super. So I really like that last slide at the end about the top tips. That was really useful to see. And I've had questions coming through as you were speaking. So I suppose a couple of questions that I was going to ask you've already answered, just in terms of what made you want to become an engineer and the favourite parts of your job. So I'll start with some questions that came through in the chat box. So one is based on the Christmas tree that you were talking about. So someone has said here that actually the design that they're thinking of making is something that will help clean the oceans. And so they're wondering what the strongest material is, and what do you use to make the Christmas trees, as they think that'll be what they'll use to put on their design.
I'm with you. That's an amazing question. So most of what we use to make these Christmas trees are low alloy steels. Now, steel is an alloy of carbon and iron. And you can change the chemical composition when this metal is all melted to get different material properties. But depending on what you're doing, you might not need a material as strong as that. For example, there are plastics which will give you really good mechanical properties, and in an application like you're suggesting, cleaning the ocean, they float as well, which can be really, really helpful. So there's no reason you can't make a metal structure float as a boat does, but obviously you need lots of air inside of it so that the density overall of that object is greater than that of the water. Sorry, less than that of the water. Wrong way around, silly David.
And then another question is, obviously from looking at that sort of big map that you had, where is your favourite place that you've worked as an engineer, someone has asked?
Oh, favourite place. Well, honestly, I've only really worked as an engineer where I am now in Dunfermline. The other places were kind of my life before, I guess. So I've worked on site. My favourite place though has got to be the factory floor. You know, I love getting my overalls on, getting to see the problems. You know, get to build a bit of product. And you don't appreciate the scale of these things. Well, these trees are absolutely massive. They're like the size of a house, and you're kind of like going, how on earth do I assemble that? And it's so easy to think that it's going to be easy when you're looking at it on a computer screen, because you just move your mouse and the model spins about, and it's all easy and wonderful, and you can see your interfaces. You know, in reality, sometimes those interfaces are covered in grease, or they're so high that you can't get to them. And yeah, I've learned loads just from spending time on the shop floor with our fitters and our mechanics, our plumbers, all these really skilled trades who make our products a reality.
Super. And I suppose a twist on that question then, Dave. So if you could work anywhere, where would be your number one place that you'd love to go to?
Oh, it's got to be a sunny beach with the laptop, sunbathing at the time, right?
Very nice.
But no, in all seriousness, I love getting in amongst it. It's actually something I expected when I became an engineer. I would get the chance to do more. A lot of the design work, you can be sat in an office or remote, or as you can see behind me, in my house just now, and you can sometimes feel a bit detached from the actual work going on. But yeah, that's my favorite place to work, is where we're manufacturing stuff, where there's the noise of cranes moving about and machines cutting metal away so that we can make stuff. That's where I really like having my boiler suit on.
Right. I know you touched on a little bit sort of at school and what kind of things you should be doing whilst you're at school and asking lots of questions. Someone's asked here if you had a favourite subject when you were at school.
Favourite subject? Yes, I did. It was PE, physical education. I loved I loved all the sport. I still do. I don't get as much chance, which you can probably tell from my several chins, to do now as I would really like. But yeah, I loved that. I also love geography. When it came to choosing my A levels, I took probably the most terrifying combination you could imagine. I took maths, further maths, chemistry, and physics to A level. An A level is similar to an advanced higher. But the reason that happened is because my friend at the time, George, and I, we had quite similar interests, and we decided that we would fill out each other's form for what subjects we're going to do. I don't recommend you do this, by the way, but we picked the hardest and most terrifying combination we could for each other, and that's what we ended up with. And we turns out we both loved them as well.
Very nice. Well, that's a good story, and thanks for sharing that with us. I have got a question here, because you have mentioned Pokemon. Of what is your favourite Pokemon, if you've got one?
Oof, my favourite Pokemon. I've just managed to get my little son to watch Pokemon, which I'm absolutely delighted about because it's reliving my childhood. I'm going to go pretty standard here. I'm going to say Pikachu, just because it's really cute and I like the idea of a little electric mouse following me about.
Yeah, and I think mine would be Squirtle, I've got to say. And then another question here of what qualifications do you need to become an engineer? We've got a question from someone.
That's a really good question, and it varies a lot depending on what kind of engineer you want to be, and what kind of field you're going into. So for me, when I started with TechnipFMC, I mean, I had my A-levels, but really I didn't have any relevant qualifications for the field I was going into. They took me on as an apprentice, and they trained me up, and so long as I kept on meeting my stage gates, they let me take it right up to degree level. So I ended up getting that degree in mechanical engineering in the end. So if you're looking at a design role, maybe getting chartership in the future, you're looking at a university degree. If you're looking at doing maybe like a fitter's job or a trade, you can go in as an apprentice, or you can get a college course. I would definitely encourage you, though, if you're looking at that kind of route, try to get into the job first, because if you've got the right aptitude, if you're passionate about what you're doing, if you enjoy it, then the company can train you up as much as they need to get you doing whatever they need you to do. It also means that if you find you don't enjoy it, then you've not just spent 2 years at college doing something that turns out you didn't actually want to do in the end. So yeah, try to go for the job first, and the qualifications will follow. I guess that's my advice.
Yeah, thanks for that, Dave. That's really good. I suppose in the minute, then, you're sort of trained as a mechanical engineer, and you're obviously looking at oil and gas at the minute. Is there any other strand of engineering that you'd be quite interested to go into, or that you think you'd be doing if you weren't doing the role that you're doing now?
It's such a broad field, and it's also interesting. I love reading about all these peripheral subjects around the edges. If you had to ask me the one thing I would absolutely love to do, and I have asked, and of course it's not really on TechnipFMC's radar just now, I would love to harvest asteroids. So I'd love to work out how we can plant the infrastructure on asteroids to start extracting the useful stuff out of there, the metals, the water, maybe the hydrogen as well, and how we can use it. And it becomes a really complicated piece of engineering, because what do you do with your waste heat, for example? You can't conduct it or convect it away because you're in a vacuum. It's a massive challenge, and I'd love to be involved with that kind of thing.
Very exciting. So, yeah,
I mean, I'd also. Oh, sorry, Misha.
No, go on. No, carry on. It was really interesting.
I mean, I'd also love to work for Elon Musk. I find the guy really inspiring. He's done so much to try and benefit the planet. So as I see, what he's done is kind of like a role model for, that's if you think you might be an engineer, try to look at what Elon's done, and he's really smashed it. But that said, I do really enjoy working where I am just now, and I do see the need for safe, ethical oil and gas production going forward, because we do need this heat, light, and power that we provide for people across the world, and it's not like we can just turn it off and move on to maybe green energy or energy storage. But I'd also love to work in those fields, by the way.
Yeah.
But yeah, I'm enjoying what I'm doing. I guess that's maybe the short answer.
Although working in space on asteroids does sound pretty cool, I will agree.
100%.
Yeah, so I've had a question from someone sort of talking about if you're an engineer competition. So they've asked, if you think back to when you were little, if you were taking part in the competition, what do you think you would have invented, and why?
Ooh, what would I have invented? I would have invented knee pads and elbow pads and a helmet and stuff that was really low profile and looked really cool. Because I remember if I was ever going on my skateboard, my mum would have me wearing these things, and they were, they were massive. They were like a helmet on my arms and a helmet on my legs, and I couldn't hardly move, let alone try and do any tricks. So maybe that's already been invented since. But yeah, I think that would have been my first point of call.
Yeah, sounds like a good invention. You saw a problem that you were experiencing as a child and tried to fix it. That's absolutely what we encourage people to do, definitely.
I'm sure I'll have about 10 slightly better ideas as soon as we finish this call as well. But that's the nature of the beast, I guess.
Definitely. And then just a couple of final questions from me. I know you've talked about sort of your apprenticeship and going into the army first before you became an engineer. How long did it take you in your apprenticeship to be able to become an engineer? How long was it?
So I was fast tracked. I was taken on on a kind of separate stream to our I guess our standard apprentices. So a normal apprenticeship in TechnipFMC is 4 years of training, and then your time served and you go into your role. For me, that was condensed down into 2 years. And the way they managed that was most apprentices will do 4 days a week at work and then 1 day a week at college. For me, I did 3 days a week at work and 2 days a week at college, so I could get all those qualifications a little bit quicker. The intention was always for myself and my colleagues Fraser, who we both went through the same scheme at the same pace, that we would ultimately become design engineers. Now I've been enrolled for about a year and a half now, something like that. So I mean, it still took me 5 years doing that kind of arrangement to go and get the degree and then start working. Well, I mean, start working in a design engineer role as opposed to in an apprentice role. So you can get those qualifications quicker if you just went straight to college and just did it. You could probably do it in a year to get to tradesman level qualifications. But what you're missing out on if you do that is all of the real world experience. I mean, for example, if you going back to steel, going back to the metal, you can learn about all the different phases that are present. That I mean, when you look at it, there's a crystalline structure that's it's what the metal looks like when you zoom in really far, and you can learn what all those structures are and how you can count the I forget the word now, lathes and features that you see in there. But in real life, no one really wants you to do that. What they want you to say is very quickly, yes, the weld is good, or no, the weld is bad, do it again. So that real world experience for me is just as valuable, if not more valuable, than the academic knowledge.
Yeah, definitely. I suppose that would be my other question, Dave. So obviously you've chatted a lot about the apprenticeship and the experiences and the skills that you learned there. Would you say that are any skills that you need to be an engineer that aren't academic? Sort of anything, any real world skills you can think of, like teamwork or any other things you can think of that will make a good engineer?
Oh yeah, absolutely. Teamwork is absolutely key. There's never a situation where I can think of where I've just been dangled out by myself and told to get on with something. You've always got a team around you. You're generally working on some small part of the bigger system, and you'll own that small part, but you've got to make sure it fits everywhere else. And you can ask advice from your colleagues. It's also when it comes down to these the tricky parts, things like welding or material selection. Maybe how you paint it, stuff like that. You'll know a bit yourself, but there'll be people who specialize in that area and they know a lot more. So you can go to these people, and you want to make that little piece that you're responsible for. You want to make it as good as you can, and you do that by working as a bigger team.
Oh, thanks, Dave. And then very last one, because it's gone really quickly. We're almost finished. What is, I know you might have already mentioned it, but what is your favourite part about being an engineer?
My favourite part, it's being able to be creative and use that artistic side of my personality, combined with, I guess, what I'm good at, to do the maths and the science. So yeah, I hope it comes across. I really do enjoy doing this stuff. I hope you didn't mind all my dad jokes that were kind of sprinkled through the presentation as well.
Well, I can't speak for everyone else because they're muted, but I enjoyed them, so I'm sure they did. And so, yeah, that's the end of our interview, everyone. So just a big thank you to everyone that's been watching and sending in your questions. I've enjoyed asking them, so I'm sure Dave's enjoyed answering them. And yeah, thanks again to Dave for taking time out of your day to let us interview you. I hope you've enjoyed it too. So yeah, there is an online survey at the end. If you could complete that for us, just to let us know how you found the interview, what we could maybe do differently next time, that would be great. And yeah, I hope you've all been inspired to start designing your entries for the Leeds War competition. And please do join us for all our other interviews. So yeah, thanks everyone, and we'll end it there.
Wonderful. Thank you very much for your time, and thanks, Misha.
All right, thanks. Bye. Bye.